Good morning, folks. Mark is at a doctor's appointment today, and Sage is about to be on a plane. So I'll just go ahead and start off this meeting. I'm not keeping real close track of all of the performance pull requests at the moment, but I know this week Mark has been looking at the Blue Store adaptive throttle and found a way to make it perform a bit better by enabling RocksDB's read ahead during compaction. Before he was seeing quite a bit of disk saturation just from reads of the disk during compaction, but with the read ahead turned on, that seems to go away. And Mark's here.
Hey, just got back.
Cool. I just started, so can you take it away from me?
Oh, sure. Let me get perf Etherpad open.
Hey, Mark.
Good morning.
Hey, Mark. This is James from Alibaba. So I was wondering whether you can give us 10 minutes to present what we already achieved with recovery, so we can present to the team of their performance we already achieved, and also their patch we are working on. So we're looking for some more comments and otherwise, especially from Josh. Josh, you are working on their recovery, right?
Yeah, that's right.
Yeah, so we want to share with what we already did, and that would be great if you can give us some more comments. And because right now we already pushed them into our production, and we fixed lots of bugs. And let's see whether we have a chance to review it, and if possible, you can give us more comments about it.
Yeah, that'd be great. Is that an existing PR you're talking about?
We right now don't. There's some PR already over there. We basically just borrow their PRs, and we have our presentation over there, so we're going to share the presentation.
All right, let's go through the pull request here first, and then maybe we can jump into the stuff that you guys have been working on after that. Does that sound good?
Yeah, cool.
Okay, cool. All right, well, let's see what we've got this week. All right. So there's been a couple of new pull requests. One of them is actually from me here. Basically, when doing small random write workloads, but also probably in some other cases as well, we were seeing a lot of reads during compaction in Blue Store. RocksDB was just kind of going nuts. And it turns out that RocksDB uses a random access file reader for doing reads during compaction, but in reality, it's almost all sequential. Even though it claims to be random, it's basically just doing sequential reads, and it's doing them really small ones, like 4K or 8K, every single time it iterates over the SST files. So it looks like sometime in the last couple of years, in the last 2 years, they implemented a compaction-specific read-ahead, and it's not enabled by default. Luckily, it actually works for us. I wasn't sure it would, just given that we've kind of got our own BlueFS backend for RocksDB, but it all appears to work fine. So that pull request is just a new default option to use that read ahead, and it makes the compaction thread go from being like 95% busy, mostly doing reads, to about like 18% busy and spending like 82% of the time just waiting around. So that's really good. In the tests I did, it didn't actually improve performance much on the NVMe drive I was testing, but it did lower CPU usage fairly dramatically. So it's a win either way. It looks like also there's a PR here from Piotr to kind of get rid of the remaining old encode decode stuff and move it over to the new framework. So that's good. There's a PR from Sage that gets rid of an unnecessary lock in the sharded op work queue. I actually went through and tested that, and the wall clock profile in the area of the wall clock profile that Sage thought it would reduce time. It didn't actually appear to do that. It didn't seem like it actually did much of anything removing it, but still it was basically just dead code that didn't need to exist. So even if it doesn't improve anything, it's probably good to get rid of it. What else? There's a PR from Sage about putting BlueFS in the middle of a shared device. So the idea behind this is that if you are putting BlueStore entirely on a hard disk, whether or not you should have it start at the beginning of the drive or in the middle of the drive. And kind of the idea is that if it's in the middle of the drive, then seeking either end of the platter will be shorter. So maybe it will take less time. The problem I see with it is that if you only say have your disks half full anyway, putting them in the middle is kind of like sticking stuff at the end. So I kind of wonder whether or not that on the whole is actually better. Maybe it is if the disk is completely full, but if it's not completely full, I wonder if you're better off either at the beginning just to be on the outer tracks, or maybe at like the 25% mark to be sort of close to the outer tracks, but still have a shorter distance to reach the beginning or to the middle. I don't know. Yeah, we'll see. I'm running through some tests on it now to just see how much it hurts an empty cluster by moving it. But yeah, I don't know. So there's that one. There was some stuff that closed. Let's see, some locking stuff, getting rid of duplicate lock acquisitions. There's this file store one here that I haven't looked at all, but it must have been pretty minor if Sage was willing to merge it.
Mark?
Yes.
Hi, my name's Andy Solomon. My handle on the meeting is Kestrels. When you get a chance, maybe after some of this and after the other folks have gone, there's one listed under no movement that I wanted to talk about today related to the fast zero algorithm for CRC. If there's any way to talk about that at the end.
Yeah, sure. I mean, if you want to talk about while we're going through the PRs too, that's fine.
Whatever you like.
Okay. Well, let's get through a couple of these other ones here, and then yeah, why don't you take it away?
No problem.
All right. So let's see. There were a couple others here, nothing too major. Oh, there's this set the HDD throttle cost. So that was actually my PR, and we're probably going to change it again. So basically, we've got this concept now where we're throttling, and at the time when I was working on this, I thought the idea was basically that we were trying to kind of eliminate long tail latency by doing these throttles, and it kind of hurts like IAPS throughput if you're doing, say, like 4K random writes, but it actually does eventually kind of start compressing things down to make your average latency go up a little bit, but your long tail latency go down. We did see that in hard disks. In some cases, not in all cases. This is kind of complicated, but the gist of it is on hard drives, we saw it around the 1.5 million mark for the cost. It doesn't necessarily happen that that's the case as you increase the concurrency. Those tests were done with an IO depth of 16, but when we bumped the IO depth way up, we actually saw that kind of benefit went away. The long tail latency benefit went away, reducing that. But then we also saw that there were some other effects that we wanted. Basically, we wanted to see the throttle coming into effect with the idea that might actually help with the new QoS stuff. So we redid some of the tests with a very, very high I/O depth, like I think it was 8,000 concurrent ops to a single hard drive. And we kind of saw that this value shifted to be closer to around 600,000 when we saw the throttle just barely starting to kick in. That's kind of where Sage, I think, wants to try having it to see if it helps once we get the QoS stuff enabled. But yeah, I don't know. I'm not sure how much this will actually help anything. But at the very least, we can see if maybe it does. So there was a bunch of work that was done on that. What else? There are a couple of things that are updated. Not probably the only real big one here is this rewrite, the deferred write handling that Sage did. I think that was failing previously and got updated.
Hey, Mark.
Yeah.
Sorry for interrupt. So when you say the QoS, which was meaning you actually testing the implementation through the DM clock, the QoS implementation with the DM clock?
I was not testing that. Well, this throttling work is basically, the idea here is that we're hopefully laying some of the groundwork necessary to make the DM clock stuff work better or work well. So this wasn't actually testing DM clock. This was just testing the throttling code that Sage merged like a couple weeks ago.
Okay. So is there any update of the DM clock development?
Let's see. Probably either Josh or Eric, if he's here, could probably give an update on that. Josh, I don't think Eric's here. Do you know what's going on?
Yeah, so basically, there's several folks working on the implementation still. Right now, we've got trying to get the basic version of the mclock algorithm merged, which is purely local. It doesn't include the distributed statistics shared by clients yet. And the issue that we were running into, like Mark was talking about a little bit, it was that the queue depth below us was getting too long, and therefore the scheduling at the OSD layer was not having as much effect as it should have. So that was kind of the latest problem to solve before the further mclock work is effective.
Okay. So you have already updated all these status to the PR, right? DM clock PR.
Yeah, the current mclock PRs are up to date and should be getting merged pretty soon.
Okay, cool. Thank you.
They're not usable for actually doing quality of service quite yet, but they're a good baseline for more work to follow on.
Okay, thank you.
All right, cool. I just noticed I've got this deferred write handling under the wrong section that actually got merged here, so I'm gonna fix that. Okay. All right. Let's see. It was Kestrel's here. Why don't you take it away?
Sure. So it's at the top of your list under no movement, common improved TRC calculation for zero buffers by
Yes.
Clancy from Mirantis. So I don't work for Mirantis or whatever, but I had an interest in this pull request, and it was impacting some of the work that I was getting ready to propose, and so I wanted to test the performance of it. I put so basically what I found is this looks much faster than anything else that's proposed on any of the other architectures. So when you pass in a buffer that's a null pointer, it assumes that the length is entirely zero filled, and on Intel it calls a specific function to calculate the CRC in that case. On Power architectures and ARM architectures, that fast zero assembly code is not present, and I was getting ready to build some fast zero or propose some fast zero code for Power PC architecture. What this pull request does is implement that in C++, and it's way faster than the Intel assembly version. And the code tests fine. The values look correct across different architectures and different algorithms. The only problem that I see with this pull request is the testing. So we asked that he put in some unit tests that show the time differences and show how much faster his algorithm is on different architectures. And he had, I think, some difficulty doing that because he's not using the high resolution timers. And so the granularity of his performance results is way too sort of coarse. If you wanted to pull in like a libRT to get high resolution timers, we could do that, but I wasn't sure whether people would be okay with pulling in a library like that to the unit tests. But I guess the summary of what I'm trying to say is I think his code is definitely an improvement, and the only sort of roadblock I see for the pull request is the unit test part of it.
Okay. I'm just kind of looking over the changes here.
So I'm not trying to ask for an answer or anything on this call. I mean, obviously, I think my hope is that people will go back and look at it after this, and because the pull request's been kind of sitting idle for a bit, and I just wanted to get it moving again.
Sure. Yeah, I suspect Sage may want to be the one that ends up approving it. So maybe we should just wait for him. He's on a plane right now, actually coming back. But yeah, well, I'll see if I can bug Sage this week and see if we can get his eyes on it and figure out what he'd like to do to move it forward.
That would be terrific. Thank you.
Cool. All right. Otherwise, there's a couple of other things. The adaptive throttle PR here, there hasn't been a whole lot of movement recently on that. Let's see what else. This separating the KV sync thread into two parts. That was, last I heard, that was deadlocking. That would be a nice thing to get in if we can, just because KV sync thread is basically quite busy. What else? There's a BlueFS write cache one. That was also failing, but I'm not sure what needs to happen to make it work. And kind of the question of RocksDB cache versus BlueFS cache is another interesting one, because if you use the RocksDB cache aggressively, then you're doing all the encode decode before it hits cache, but it's smaller, so you can fit more stuff in cache. Whereas on the BlueFS side, oh wait a minute, no, I'm sorry, I was thinking ONode cache, not BlueFS write cache. Yeah, I should probably find out what kind of the rationale for the BlueFS write caches versus using the block cache in RocksDB. I'm actually not totally sure. All right, what else? There's been some RDMA work with zero copy, but it looks like that hasn't moved forward this week. Yeah, just kind of a variety of other things. Yep. Okay. So let's see. For discussion topics, we already talked a little bit about compaction read ahead and how much that helps. Yeah, so KV sync thread. A lot of time in there appears for like small random writes appears to be spent doing key comparisons in RocksDB. So it'd be good to see and kind of dig into RocksDB more and figure out if there's anything that can be done there. and also probably think about ordering and whether or not we're kind of giving it data that is easy for it to compare. Igor had kind of mentioned maybe there was something we could do there, but yeah, we'll see. And then there was one other comment here about bufferless CRC cache seems to actually be useful and help. I'm not sure who added that.
That's me.
Okay.
So I will... Yeah, go on.
Oh, go ahead, Piotr.
Okay, so I have actually pushed out the PR that adds a missing CRC cache miss per counter. This thing will help out tracking if and how effective is the CRC cache in buffer lists. What I was expecting to see that is that the CRC cache in buffer list is pretty much useless or close to useless, and what I found out is that it's actually quite opposite. In case of file store, there was 23% efficiency and 44% efficiency on Blue Store. So this is actually quite high, especially in case of Blue Store. And for actual data on some testing I've done, you can see this spreadsheet. Oh, it's going to break the link. I can paste this link. Sorry. You need to
okay.
insert the %20 between CRC cache and cache, so this will actually work. Anyway, I haven't performed any significant testing with this, but these initial results are quite interesting, and I hope this will help out seeing whether we should get rid of the CRC cache or just reduce it somehow. Because another thing I have seen is that in most cases, the CRC cache was just consisting of one element, meaning that just one CRC was requested and cached and nothing else. I don't have right now any information on whether this was followed by any cache hits or not, or this was just a single access. But still, this is something we can something you can test out further. Because I have posted a link on IRC on Ceph Devel to the text file that pretty much displays during the testing how large was the CRC cache, and in most cases it was simply empty, and next one was just of one element. So in most cases we could get rid of this CRC map and just use some kind of single container and contain just the last CRC calculated, and that would probably reduce the memory and CPU utilization, especially during destruction of buffer pointers. But this is right now just a somewhat a guess. So this needs further research, and that's why I have pushed out this PR so everyone else can see it for themselves without resorting to some crazy hacking.
Sure. That's really cool. I'll see if I can try to take a look at it this week. If not, maybe next week. But yeah, that'd be interesting to see. That's good.
Cool.
All right. Let's move on now to was it Alibaba, I think, from earlier?
Hey, we're here.
Hello. Yes. Would you like to do your presentation now?
Yeah. So before we make a presentation, Pietro, I was wondering for your pull request, have you ever doing the benchmark. So how much performance you make improve through the copiness, right? In Liberados?
Can you repeat?
The how much performance improvement?
Yes. How much performance improvement?
Have you ever done the benchmark? How much comparing to the version without your pull request? Do you have any performance data that can show you really gain the performance improvement?
You mean this CRC cache?
Yeah.
Actually, I haven't, but
I also see another IFC like a copiness right in Liberados. See, this is another PR. Have you ever done the performance bench?
actually no, because when I was issuing that PR, I haven't had any reasonable cluster for my access, so this was just somewhat educated guess. Because if you are copying a lot of data back and forth, then you are pretty much crashing the processor caches, and you are going to pay penalty for that, and it's always hurting. Also, you will have to pay penalty for extra memory. So this was so getting rid of extra copying would be beneficial in any case.
Okay, cool. Thank you. Okay, we're going to share our presentation right now. Share screen. Oh, damn. So, share. So, Mark, do you see my screen?
I see a screen saying you are sharing your screen. There you go.
So, do you see the presentation, right?
Yes.
So we already actually in the previous performance meeting, we already explained why we are so care about their performance, especially the tail latency and the average latency, just because the applications right now we run against the Ceph cluster is so demanding in terms of the tail latency and the average latency. So we care every corner of the chance, every chance of improving the tail latency and average latency. And this is kind of background I want to share with all of you guys. That's another reason why I asked Piero of what the PR he is working on in terms of copiness in Rados. We care about their, whether there's a data to explain whether they can improve the tail latency or not. So we have several folks in their phone call as well. So just in case if I cannot explain in clear, so please come out and support me with a more detailed explanation. So we have especially for the Ceph recovery, we have lots of tests, especially finger injection tests in our Ceph cluster. Basically, we try to down one OSD to one rack to see how the Ceph cluster behave when the recovery gets started. So we don't want to the front IO, normally the application IO get blocked for all the time, because some of our application is an e-commerce application, and there's no way to block them. And if, for example, down, if the one IO from e-commerce application down, which was meaning either one payment or real payment, or either one real, e-commerce transaction get blocked, that's for sure not going to be acceptable for us. So recovery is one of the place we pay lots of attention, because OSD fail is normal in the big cluster we are running right now. So we try to see whether there's a way to mitigate the IO impact during recovery. That's the background of Ceph recovery improvement. And we do. Go ahead. Are there any questions? If not, I'm keep going. So we do some research, of course, in the Ceph community and found several pull requests which he already worked on. The first one actually is from Zhiqiang Wang. He's from XGuy. He has a patch. He has a pull request in there. They call it asynchronous recovery. Basically, once there's a IO come in during the recovery happen, and they normally let IO execute first, then recovery going to do the asynchronous way. This is the patch about the asynchronous recovery. The other one is called partial recovery. Actually, from Yawning, he's from NetEase, another big internet company in China. He tried because normally their data mismatch is only a partial of their one object. For example, you have a 4 mega object, but only a portion of their object is missing or is or need to recovery. It's just like 4K or 8K. There's no necessary to copy all of the 4 mega for their data recovery. So this is called a partial recovery. Basically, all of our recovery improvement are based on these two PRs. Of course, we fixed several bugs related to these PRs, but these PR also have an limitation. Later, I'm going to explain why this two PR and limitation. But so far, it address our problem very well in the block storage in the RBD libre world. But therefore, so far we don't consider so much of their Ceph or RGW support. So we only so far support their RBD. Here's our test environment. This is just our experimental environment, but in our real deployment, we have way bigger clusters than that. So we just today want to share with all of you guys the performance data we already achieved in the small testing environment. Our testing environment have 3 servers, 24 OSDs, and of course we use a Ceph 10.2.5 Dual version plus all of the patches. And we create a 100 gig RBD image and FIO 4K run and write. So here there's a data. So Nimi, are you on the line?
Yes.
So Nimi is another Ceph guy from our team in Alibaba. He's going to explain all of the performance data. So Nimi, can you keep going?
Yeah. So for this test, I run a 5 minutes test to see the improvement for both patches. So see the timeline here. So at the beginning, I run FIO. Then at 60 seconds, I stop one OSD, and in a 2 minutes timeline, I restart the one I just stopped. So the recovery begins. And I capture all the FIO data, see how the improvement looks like. James, could you go to the next slide?
Sure. Do you see the slides? Partial recovery?
No? Oh, yeah, yes, okay. So the first one is the improvement from the partial recovery PR. See the green part? The green part is the recovery part. And the red line is the patched version of the recovery. The blue one is the unpatched version. So we see from here we got a lot of improvements from the partial recovery, and it actually recovered much faster than the unpatched version. In about let's say 30 seconds. Yeah, about 30 seconds. The recovery was done in about 30 seconds, and in the unpatched version, it's about probably 80 seconds, I think. 60 to 80 seconds. Yeah.
So not only the performance get improve or not, but also time-wise, it get shrink or not, right?
Yeah.
for the recovery. Okay, cool.
Yeah. Okay, let's go to the next one. This one is the asynchronous recovery result. The recovery time is kind of similar as the unpatched one, but the average performance is much better, although it's go up and down. But in averagely, it's much better than the unpatched version. Okay, let's go to the next one.
So next one, we combine the partial and asynchronous recovery into one, and this is the results.
Yes. Yes.
So normally we average rise we feel we get 80%, almost 60 to 80% performance gain in terms of tail latency and average latency during recovery stage. Because in the beginning we normally see the IO drop to 0 if recovery happen without any patch. But with partial and asynchronous patch, of course we fix several bugs. We can later on mention about it. And we generally speaking, we almost get 80% IOPS improvement, and of course latency and tail latency. So this is very important to us, especially for other workload like OLTP workload and the e-commerce workload. As I said again, we cannot tolerate any of drop to 0 happen during any of the maintenance of the cluster. Do you have anything to add for the performance data mean?
No, let's go to the next slide.
Okay. Here is what we think for to-do list, especially we are looking for help from Josh for more comments and more input. We still found some I will drop to 0 during pairing stage, even though it's very short, in like 1 second. During 1 second, as I said again, we try to avoid any of chance to let IO drop to 0 from the client side, which is normally from the e-commerce and our MySQL applications. This is the one right now we try to address. Second one is, of course, right now their patch only works, or most of the time works for RBD. We don't have a chance to check for RGW or CFFS. So this one is a big is a big concern over here, and we right now need to do more intensive tests. We already do lots of tests, and we fix several bugs. And these several bugs need to, we already fixed, I think, 3 or 4 bugs. The bugs is related to attribute inconsistent or OMAP inconsistent. We only find one instance of data inconsistent, but we fix all of them. And but as I said again, all of these test cases need to be developed and be be well maintained. But the chance is whether this PR can get into their get into the master, that need to be decided by Sage or Josh. And of course, we so far don't have a way to do to support the recovery of the EC. And then because we need probably going to use EC as well. So how we going to support EC during recovery without a drop to 0? This is another concern we have right now. Yeah, Mark, that's pretty much we have today. So we share with especially Josh and Sage, but Sage today is not here. So Josh,
Yeah.
please.
So thanks very much for sharing this. It's very interesting to see your performance results in particular. You have a PR as well for the. I've seen the async recovery one, but I haven't. Do you have a link to the partial recovery
Here.
you're talking about?
Yeah, I'm going to send you the links if you like. But here, basically, we need the two basic PR recovery PR we are working on. We also have several bug fix towards these two PRs. And if let me know what you think, and we can either work together through the email or through the RC, or even though which direction you want to work on. We are looking for your advice.
Yeah. So in terms of the async recovery PR, if there are a number of ways that it does things that probably aren't quite correct in terms of upgrades, and like you mentioned, in terms of it doesn't handle erasure coding yet.
Mm.
So on that one, I was working on a slightly different approach that I hope to have ready for Luminous.
Mm-hmm.
So I can share my existing branch with you guys. Maybe we can collaborate on that to get that ready. I haven't taken a look at the partial recovery patch in depth yet, so I want to take a look at that and see what we want to do with it.
Mm-hmm. Yeah.
But it's great to see those performance results, and that's exactly what we've been hoping for with that kind of basic recovery approach.
Yeah, I also want to let you know we do have a real workload work on running every day on with these two PRs, and there is so far we're stable now. So if you can consider about it as well, that would be great. If you can bring some of these implementations into your own implementation, that would be great too. Because as I said, we want to have extremely good tail latency and their performance. That's what we really care about. And probably next week we're going to share with you guys another issues we are working on. It's also about tail latency and average latency.
Okay.
So
Yeah.
Josh, I'm going to send you an email and put together our folks from Alibaba who are working on these two PRs, and then we can start the discussion through the email thread. Is that okay to you?
Yeah, it sounds good.
Okay, cool. Yeah, Mark, that's all.
All right, sounds good. Thank you much. That was quite interesting. All right.
So Mark, so probably next week, can you help us to allocate another 10-minute session, because we're going to share another performance improvement we made, and it's a decrease the tail latency almost 4 times with a certain workload. So we also want to share with all of you guys and looking for your opinion as well.
Definitely, that would be great.
Okay, cool. Thank you.
Yeah, no problem. All right. Does anyone else have anything that they would like to talk about this week?
Hey, Shen, are you here? Shen, this is another folks from Alibaba. He has some he has some. Hey, Shen, you have some proposal to improve the performance, and you have some questions. Can you share? Because Josh is not here, but Josh is here. Can you share with Josh?
Sure. So we are trying to optimize performance on the OSD side. So far we have done some latency break. So we saw some non-latency spent on the, for example, the Q transaction function call when the PG worker prepare the OP and finally call the Q transaction, which involve the triggers actually. For example, we are using the Blue Store backend. So Blue Store's Q transaction will be triggered, and the PG worker will execute that function actually within the holding the PG log. So we are thinking about can we make this function as to be executed by thread pool inside the object store backend. not executed by the PG worker thread. So PG worker thread just actually do the put this transaction request to the those thread pool inside the object and the blue stored backend side, and then we can return that PG worker thread and release the PG log. So that actual thread pool inside the blue store will actually execute that Q transaction function call. This will make the PG worker can quickly go back to fetch another request and can release the PG log quickly than before. So I'm wondering if this can help the reduce the improve the IOPS basically.
Depending on the kind of workload, we definitely see contention on the PG lock, especially with something like 4K sequential writes. That's a really common one where it looks like, at least in BlueStore, I haven't looked at FileStore recently, but at least in BlueStore, if you do wall clock profiling, you'll see that the PG lock is very much contended.
Yeah. So we do some of experiment in our site. We think we can save like 50 microseconds, but we right now not 100% sure whether it's safe because we kind of like make a asynchronous you know, in the beginning we have a synchronize, we have already have a write synchronize, but all of the metadata allocation is still synchronized in the synchronized way. But right now, between the PG and the object store, we kind of like make the asynchronized way even longer, so which can release the PG log sooner than later. It is for sure going to save their latency, but so far we don't know whether it's we are not 100%, even though we put lots of time to research, but we still need looking for Serge or Josh advice whether it's safe or not.
Yeah, so to tell whether it's safe, I need to look at the code in more depth. But one thing that springs to mind is that it might make more sense to, in the long term, to try to make the interface, instead of doing a single callbacks for each individual completion, have a single callback that gets called that then goes and inspects all of the IOs that have been completed, kind of like an IO event style AIO callback instead of a completion per op. I would avoid a lot of the PG lock switching between different contexts. Is that kind of what you're describing, or are you just describing dropping the lock sooner?
Drop PG log sooner than later.
Okay. Yeah, I'd have to look at the code to see whether that was safe.
Okay, I think we're going to implement, and also of course we're going to have a performance data, but in the meantime we will get in touch, and especially you and Sage, and just in case whether because this is going to impact the stability or not. We are not sure whether it's safe. So we will get you guys involved and let you know the progress we made. Of course, whenever we finish the development, we'll create a PR and looking for your advice as soon as possible.
Sounds great.
Okay, cool. Okay, Mark, that's pretty much done from our side. Thank you.
Okay, good deal. Well, anyone else have any last minute things they want to bring up? All right, well then let's wrap it up this week, and we'll reconvene next week. Thanks much, everyone.
Thank you, Mark.
Thank you. Bye-bye.
All right, have a good week.